Okay, I have 3 questions I want to go over with you in reference to your Chapter 5 tests that were commonly missed questions. So let's take a look at them. I think this would be a good way to start reviewing for your semester exam. First one would be the mean value theorem question. And maybe this was confusing because there's a question on in your review packet where you just had to find the average rate of change. So you really have to read the question, and since this question is asking for C, this is kind of like the full mean value theorem question. So just a quick reminder, our mean value theorem states that if a function is differentiable and continuous on a given interval, then there is some C value that's a particular x value at which f prime of C, it's my derivative, is equal to the difference quotient, so f of b minus f of a all over b minus a, and that would be the average rate of change of your given interval, which in this case is from 1 to 5. So I know when we were doing notes on this, I set this up in 3 parts, so let's just work through those 3 parts. And the first part was find the average rate of change, and that's going to be using our difference quotient. So that's really f of 5 minus f of 1 all over 5 minus 1. It gives me a 4 in the denominator, and I'm going to let you work through the numerator a little bit more specifically. I'm just going to kind of jot down what I got. I got radical 4 minus radical 1, which is obviously, sorry, radical 4 minus radical 0, which is 2 minus 0, which is 2 over 4, which is 1/2. That's the answer to part 1. If they had said, what does f prime of C equal? If the answer right here had been f prime of C, then your answer would have been 1/2, and that's what a lot of people circled was 1/2. This is where I don't like multiple choice questions, because if the answer hadn't been there, you probably would have kept going. So the next thing is we need to find, part 2, is find the derivative. The instantaneous rate of change is what we said this refers to. And then we're going to basically set our 2 answers equal to each other. And hopefully it's coming back now. Derivative, so I have function is square root of x minus 1, but I'm going to write that as x minus 1 to the 1/2 power. And then the derivative would obviously be 1/2 times x minus 1 to the negative 1/2 power. Let's rewrite that as 1 over 2 radical x minus 1. I am considering chain rule here because my inside is x minus 1, derivative is just 1. So if I did make u equal x minus 1, du dx would just be 1, and I don't have to worry about it in this case. So my last step is going to be, let's set those 2 things equal. So I'm going to take this and set them equal to each other. And that's going to, that's going to lead me to, well, I still have to solve it, but 1/2 is equal to 1 over 2 radical x minus 1. I'm actually going to reverse it so it looks a little bit more like what I have up here. So my derivative is 1 over 2 radical x minus 1 is equal to right-hand side. My average rate of change came out to be 1/2. So this is an equation that's representing your mean value theorem that I've written in general form up here. Now specifics to this problem. And now I'm just going to solve this. I've got a proportion. So to solve a proportion, I'm going to cross multiply would be my thought. So 1 times 2 radical x minus 1. Taking this cross product, I get 2 radical x minus 1 is equal to 1 times 2 is 2. And I'm going to divide by 2 on both sides. And I'm going to get radical x minus 1 is equal to 1. And then I'm going to square both sides. And I get x minus 1 is equal to 1 squared, which is 1. So x equals 2 is my final answer. The math wasn't bad there at the end. I know it was a lot of us just forgot to finish the problem. So x equals 2 was the correct answer to that problem if we go back up to here. And like I said, most of the wrong answers were 1/2. Second question that was a highly missed question, this is actually the most missed question on the test, is the natural log question. And I think some of it is we're having troubles with natural logs. So I've put that mental note to review more of that second semester. But the bigger issue is that we didn't finish the problem at all. So those of us that were able to solve the natural log just stopped halfway through the problem. So we're trying to find what would be the minimum. General idea, if I'm finding a minimum, I'm going to take the derivative, set it equal to 0, find critical points, and then do some kind of analysis. Since I have an interval, I can do just my absolute value extrema test, or I can do my number line analysis, either one. So let's take the derivative. Derivative in this case involves a product rule. So there were a lot of you that got the product rule. There were some of you that just did derivative of the first times derivative of the second. So first times derivative of the second, derivative of natural log of x is 1 over x, plus second is natural log of x times derivative of the first, which is 1. So I'm going to simplify that to x over x is just 1, plus natural log of x, and that is my derivative. To find critical points, I'm going to set that equal to 0. And then that's going to give me a negative 1 is equal to natural log of x. And you can, and you should, and you need to be able to do this in your head without a calculator. So the way I think about this, if I'm ever trying to solve for the inside of a natural log, or any kind of log, is I'm converting it to exponential form. So remember, there's a conversion there. My base of a natural log is e, and my conversion is that e to the negative first is equal to x. Your base of your log to your answer is equal to the inside. Okay, so if you don't remember that, go back to some prior time when you learned log base a of c is equal to b, means a to the b is equal to c. That's the same thing I'm using, it's just written a little bit different way. Okay, so back to my answer here. E to the negative first is equal to x. E to the negative first is 1 over e to the first. So that would have been the correct work to get you to the answer choice of C, which is not the correct answer because all you did is you found a critical point. So I now know that the critical point is 1 over e. Now, the real issue, and that's important, but the real issue is even if that ends up being the point at which there is a minimum, the question is asking the minimum value. They're asking for the y value. So if they say where does the minimum occur, then they would be looking for 1 over e possibly. But the question is asking where, not where does the minimum occur, what is the minimum value, which implies we're looking for a y value. So I would probably at this point do a quick little number line test. So I've got to do my x values and then my f of x values. F of x, not f prime. I'm not looking for sign here. I'm just looking for what are the values. My interval, recall, was 0 to e, with 1 over e being my critical point. And I'm actually going to cross out 0 because it's an open interval on that end. So my interval, just a quick look back up here, my interval was open on the left side. That means that 0 can't actually be a value. Natural log of 0 doesn't exist, and that's why we can never reach 0. E is a potential minimum point. So my minimum is either going to occur at the critical point or it's going to occur at the end point of E. So all I got to do is test those two values. My original function was x times natural log of x, and I'm just going to plug in both of those values. So for 1 over e, I'm getting f of 1 over e. Okay, that one looks a little difficult. Let's do f of e first, and then we'll come back to that. E times natural log of e. So natural log of e, remember I'm thinking e to what power gives me e? And that's just 1. So this ends up being 1. So answer here is e times 1, which is e. So f of e is actually e. F of 1 over e is going to be x, which is 1 over e, times natural log of 1 over e. So I'm trying to figure out what this natural log of 1 over e is. And I'm thinking that, recall, that was really natural log of 1 over e is e to the negative first. So e to what power gives me e to the negative first? And the power is negative 1. So this actually ends up being just a negative 1 here. So I have negative 1 over e times negative 1, which gives me a negative 1 over e. Okay, that was all natural log work. My answer here is negative 1 over e. As the y value when my x value is 1 over e. I'm looking for the minimum, and I suppose that you probably could have done less work because I actually found the values. As soon as you knew that this was a negative value, you know that's your minimum because your other possible answer is e, and obviously that's a positive. Okay, once again, I did throw this question out because I realized there was a lot of natural log work that was confusing you guys and it wasn't so much calculus. But we did not do this whole second half. We skipped, and we needed to either do that or we needed to do a number line analysis where you put 1 over e here, and then you figured out your derivative signs, and that might have been easier. I don't know. We'll work through it that way too. If you wanted to just figure out what the function was doing, I could have said, okay, my derivative is 0 at this point, and then let's plug in something bigger and something smaller. And this time I'm plugging into my derivative, which is 1 plus natural log of x. So if my derivative is 1 plus natural log of x, then I'm going to plug in, I don't know, e is bigger, so f prime of e is 1 plus natural log of e. Natural log of e we said is 1. So let's make that a 1. 1 plus 1 is 2, so I'm getting a positive. Since that's a positive 2, which means my function is increasing. And then I'm going to have to test something on the other side. F prime plus, f prime of, I want to do 0, and here's the problem. Natural log of 0 is undefined, so I can't really say 1 plus undefined is 1, so I'm really struggling with something to put in here that would be easy to do without a calculator. So 1 over e squared is probably the best I can do, since that comes out to 1 plus natural log of e to the negative second, which becomes negative 2, and this is about as difficult as the other way. I get negative 1. So it would have worked, but it still had some natural log work that was difficult. Okay, so correct answer there should have been negative 1 over e. FYI, just for future, negative 1 over e. Finding the minimum, we need to work through the whole problem. I'm going to stop the video there. I'll make one more going over the free response question that a lot of you struggled with.